Adding and subtracting rational expressions. Okay, we're going to look at adding our rational expressions here first, and whether we're adding or subtracting, the one thing that we need to make sure that we understand is that we have to have a common denominator in order to add or subtract fractions. So the easiest way is to kind of follow these steps up here. We need to factor all denominators, and we need to determine the least common denominator. Okay, now the least common denominator will contain the factors of all the denominators. Okay, and then once we know the least common denominator, we'll use that to build equivalent denominators in each one of our rational expressions. And then we'll add or subtract the numerators, and we'll move on. So the first thing we want to do here is look at our two rational expressions, and I'm going to factor the first one here just so that we see it. This is the difference of squares again. And you'll notice that here in the first one, in the first rational expression, we have an x plus 1, a factor of x plus 1, and in the second one we have an x plus 1 and an x minus 1. So our our least common denominator in this case will be x plus 1 and x minus 1. Each of them need to have that in the denominator. Okay, so I'm going to start in with my work here. If you look, the first expression, which is 1 over x plus 1, does not have an x minus 1 in the denominator. So I'm going to put one there by multiplying by x minus 1 over x minus 1. That's essentially multiplying by 1. So it doesn't change the value of that expression. And so we're allowed to do that. Now our second rational expression already has an x plus 1 in the bottom and an x minus 1 in the bottom, which is our least common denominator. So we don't have to touch that one. That one is good to go. Once we have our common denominator in both of these fractions, all we have to do is add the numerator. So really what we have here is x minus 1 plus 6 all over our common denominator. So we have to build our least common denominator and then add the tops. Okay, once we get that, all we have to do is bring together like terms. So we get x plus 5 all over x squared minus 1. Now actually I'm going to leave that in factored form just for a second to make a point. The last step that I have up there is to check for new opportunities to reduce. So once we combine the top there, we need to look to see if anything cancels out. Now in this case nothing does. We don't have any common factors. So our final answer here would be x plus 5 over x squared minus 1. And we would want to make a note, okay, that x cannot equal plus or minus 1. Okay? A little more difficult example. Again, first thing we want to do is factor to help us find the least common denominator. So I'm going to go ahead and factor this first one here. What we see, we can take out a 2 and an x, okay, and we'll be left with x plus 2. In my second expression here, you'll notice again it's the difference of squares on the bottom. Okay, and then our third expression doesn't factor, 1 over x. Now, after we get done looking at that, we can see what our factors are. The first expression has a factor of 2, a factor of x, and a factor of x plus 2. So that has to be in my least common denominator. Now, if we look at the second one, it already has a factor of x plus 2, which we already have in our least common denominator up here. So we don't have to worry about that, but we do need to put a factor of x minus 2 into our least common denominator. And here on the last expression we have an x, but notice we already have an x in our least common denominator. So there's our least common denominator just by looking at the factors, factored form of each one of those. Let's look at what we need to do. What we need to do, the first expression has a 2x and an x plus 2, but it doesn't have the x minus 2. So let's go ahead and we'll make that, or we'll put that in the denominator by multiplying. So I'm going to multiply by x minus 2 over x minus 2, the first expression. That gives me now my common denominator there. In my second expression, I will need to multiply by a factor of 2x. So let me write this out. Then I need to multiply this one by 2x over 2x. And lastly, my last expression, it needs the most work here. It needs to be multiplied by 2 and x minus 2 and x plus 2 and x minus 2. Now all of those have our least common denominator in them. Okay? Now, once we have all of those with the least common denominator in them, we need to go ahead and distribute here on top and start combining like terms. So 1 times x minus 2, okay, is x minus 2. 3 times 2x would be plus 6x. And negative 1 times all of this, and if you need to stop and work this out, go ahead, but what we're going to end up with here is minus 2x squared minus 4x. Okay, all of that will be over my common denominator, least common denominator. Okay? Alright, now we just need to combine some like terms. So if I start doing that, you'll notice that I end up with negative 2x squared. I'll have plus 3x's. Okay? And then I'll have a minus 2 here. Okay? All of that would be over 2x times x plus 2, x minus 2. Now, once we get to here, what we can do is we can look for opportunities to reduce, and the only way that's going to happen is if the top here can factor. But in this case it doesn't. Here's how I know. If I multiply negative 2 to negative 2, I get positive 4, and there are no factors of positive 4 that add up to be 3. Okay? And if that's the case, then we can't have anything factor. Alright, so we just want to write our answer in the final form. Now, what most books will do, and most books will do, they don't like this negative out in front of your leading coefficient on the top there. So they're going to factor that out to the front. So we had negative, the quantity. Now we would have to factor that negative out of everything in the numerator. So we get 2x squared minus 3x plus 2. Okay, all over 2x cubed minus 4x. And that would be your final answer. And again, we want to make the note that x cannot equal 0 or plus or minus 2. In this case, if you put that back into the original equation, you would get a 0 in the denominator.